Hello, welcome to another coding session. Here we go again. I think it was in the last session, at the end of the session, I attempted to split everything out into smaller files because my files were getting huge. I'm honestly a little bit hesitant to do it because although, the conventional wisdom says that you should do that and it's easier to organize and blah, 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 I'm honestly skeptical whether that's true. I mean, that's what I normally do, but anyway, I had a go at it actually offline. I just wanted to sort of see what was involved, what needed to be done, but it ended up being quite a long process to split everything out. And because it took so long and I thought it was probably not that interesting, I thought I would just finish it off, not record it. So I have a new commit here, split into smaller files, and you can see here I've got a whole bunch of folders here. So I'll just kind of go over basically what I did, and I guess a little bit about how it works in Odin. So I've made a folder. I mean, if we look at our compiler architecture, very complex architecture, there's kind of like these circles are sort of like the data, I guess you could say, and these boxes are the processes that it goes through. So the main data stages are source code, tokens, and AST. So I have, source, tokens, AST, and then I also have, tokenization, parsing, type checking, generation, which are all these boxes. So that's kind of how I've organized it. I also have this program folder which just has one file. I'm not sure how necessary that is anymore. I was trying to get used to the whole package thing and the dependencies and things, because you can't have cyclic dependencies. So I think that might be why this ended up in its own package. So in Odin, it's a bit weird actually. I'm not sure exactly why, but you need to have a folder. The package is like at the folder level. So a folder is considered a package, but then you also have to have the package name at the top of all the files within the package. I guess it could potentially be different to the name of the folder. I'm really not sure why it's like that, but that's how it is. And then, so if I go to main, you can see that I import a few of these packages. And then I need to prefix with the package name anything that I'm using from that other package. Within a package, you can reference other files within the same package, which is what I had been doing before, and you don't need to prefix at all. You don't need anything like this. But when you're referencing other packages, then you need to prefix. Which is similar actually what I kind of do with my language, except mine is at the file level, not the folder level. Yeah, I think Ginger Bill, the creator of Odin, I saw him talking about how he tried different sort of granularities of, I guess packages or modules or whatever you want to call them. And he landed at the folder in the end. I don't know, I haven't really thought it through much. I'm at the file at the moment. So the other thing to say is that like within these process folders, there are lots of files. Like within, AST, there's not much. Source, there's only one file. Tokens, only one file. Tokenization is actually like, there's not much to it. It's just like, it's only a couple hundred lines is the whole of tokenization. So it's basically just one file. But in these other process ones, more or less, I have files now for each production in the grammar. So in our grammar here, if I can open it properly, there's all these productions. So, a statement if, for, scope. So you're going to see all that here, statement if, for, scope. So there's all these ones. And then there's also this types file, which is just like there's not much in here actually, but this is just a type that I use within parsing. This is the context. I guess I could have gone with file name context here, because if we go to type checking, Yeah, we have a context, and generation, we also have a context. So actually, maybe I'll call that context for consistency between them. Do I have anything else special in here? I don't think so, actually. But I think in type checking, there's like, yeah, I have like types, which is where we list our different kinds of types, and we have a whole bunch of utility procedures to do with types. And util is just like, well, there's only one procedure in here, but general kind of utilities. All of this is subject to change, just like everything. But that's kind of more or less what I've gone for. So if I go into 4, type check 4 is the only procedure in here, you know? So it's very much more granular than it was. Okay, so now that I've, oh, and the one other thing, yeah, it'll be in type checking a lot, maybe even in the 4. No, 4 does not have any LHS expression. See this here. This is a revamp of the kind of logging, I guess. So this position message has this the source position, which actually is something I renamed. So this is basically saying, you know, where in the source code we are. See, it's part of the source package. So, you know, what file are we in? What's the line and column? And so this is a convenience procedure which does this formatting, which I think is a bit more concise. So the logging has changed a little bit. So if I like open our example program, maybe I'll just turn off the tests so that it doesn't take forever. And then I introduce an error. So if I say like, just put a hash there or something weird, we should get an error. Invalid token type colon. So this is the error, and they always should be always prefixed with this. So it's like file name colon line colon column. So it's a bit more concise, or you know, a bit more compact. I think I like it like that. So that's one thing I changed. I think that's about it. I think I've talked about that for enough. We did some allocators in the last session, and what I want to do now, actually, if I reopen this, is I want to do a VRAM allocator. At the moment, we do all of this to allocate data on the GPU, in VRAM, that is. And I want to replace that with something like this. So, you know, we have like these static allocators. So now I want to have the VRAM allocator. So I can just say, hey, I want, this is just saying a slice of vec3s at VRAM. So I want to put a size in here and just make it an array. Unfortunately, we can't do dynamic array sizes yet because we haven't had any dynamic allocators really. I mean, we do have the heap allocator now that we just introduced, but we didn't really think about it at the time that we should do, you know, something like this. Oh no, not buffer size, it would be vertex count. Because we have a vec3 for every vertex. So this is ideally what I'd like to be able to do, but we don't support this yet. So instead, vertex count is triangle count times 3, triangle count is that times that. So for now, I'm just going to do 64 by 64 by 3. That should be the amount of vertices. So I want to do that instead of this. So initially, our VRAM allocator is basically just going to be an OpenGL buffer allocation, just because that's the easiest thing to do right now. Eventually, I'd like to move to like OpenCL or something. I mean, ideally, I'd like to be able to go down to the assembly on the GPU, but I think that gets very complicated. Love me some tea. So let's see, how can we do this? at the moment, how do we do our heap? If we find heap, we have two places. We have type checking. So here we're saying we have to have a reference. So this is all very very specific code that I'd like to change later on, but basically I just want to treat VRAM the same as heap here. You can only allocate a pointer to something. So I should have to do that. I get a pointer back. I get a pointer, but what it's pointing to is this amount of memory which has been allocated. So that's the type checking. And now we go to generation. So now we have like allocate heap here. And what I want to do instead, I think I'm going to kind of inject a procedure call, basically. So this allocate heap, which does this, so it's basically like a hard coding of stuff. Instead of having it like that in our allocators file, since we have everything split up so much, I think I'm going to actually create some procedures in our standard library. So we go to standard library. I guess after mmap makes sense. Where's mmap here? So if I make an allocate heap here, I might make like an allocator type, which is a proc. Why not, since I have this feature? So that's what an allocator should look like. It's a procedure that takes in a size and gives back a pointer. I just use I8 for pointers where I don't know what the pointer is. So what does a heap allocator look like? It basically looks like this, right? This here, I think we will not make part of it. And that actually is this, right? So we should be able to just return that. But this is the size. This is something that's a little bit funny in my language, because the name of the parameter is like considered part of the type. So even though nowhere here have we mentioned size as a parameter, it is available. So I do concede that that is a bit strange. You just kind of have to know that you can use size. And then we're going to have an allocate VRAM. Which we need to implement soon. So then when we get to generation, I do want to do a stack. So this here, basically the stack allocation, and this we're going to get rid of. Yeah. So that's the stack allocation, and then we're going to do this. So I think we established in type checking we said must explicitly assign. I think for these I'm going to explicitly say that you can't assign to them. Cannot assign when using allocator blah. It's a bit of a weird message. But basically what it means is you can't do this. You know, I can't assign. Probably going to get, well, it doesn't compile right now. Okay, so we kind of want to dynamically choose what we are generating, which I do feel like is kind of a type checking thing. So maybe we'll put it here. Although we do need to know the byte size as part of this. So maybe, no, I think it's good to do it in type checking. So then we can also type check the thing that we've just created, if that makes sense. So if I go like allocator node, that would be a call. AST node. I have to put AST dot now because AST is its own package. And we add to that and so this is going to be, I guess, the identifier standard lib. So this is kind of like not great because it assumes that we've already imported standard lib and that we've imported it with the name standard lib. So this is really like a stopgap solution. It's not a permanent solution. The more permanent solution actually is that I would like this to be any expression. This could be any expression that evaluates to an allocator procedure. I think that would be very nice, but I think that's a fair bit more work. So let's do something simple for now. So here I want, I guess, another one, but this is the allocator func, I guess. And allocator func is maybe I can just do it in line. It's not so much. It's basically a concatenation of the allocator and was it allocate underscore? So then that would call, you know, like allocate underscore heap or allocate underscore VRAM. Allocate underscore the allocator, because we've already established that we're just doing a heap or a VRAM. So that should be a proper call node. We've also established that there is no right-hand side. So now what I'm going to do is I'm going to create, so we need to say equal or assign. It's an assignment node. So basically to our node, we're going to add these. The operator node and the allocator node. So that basically means that it's going to take the result of this allocation procedure and assign it to our newly created stack variable. And the stack variable is a pointer to one of these. So it's just a pointer, right? That's what we're returning. And that's what we're allocating on the stack as a pointer. So I guess we also need to type check right-hand side expression. What does that take? Node context expected type. I guess it's probably better to do it like in place, context, and what are we expecting? Let's just not have an expectation. We've already established that it's a pointer, so it could be a pointer to anything really. I don't think we need to narrow it. Okay, but I think that should add all the required type information to this, which is why the main reason that I want to call this is so that type information gets appended onto this structure, this AST structure. The one thing we are missing though is in our call, we have said what we're calling, but we have not said what parameter we are sending to it. So probably, it's actually probably going to fail allocate heap. It's probably going to fail type checking. Cannot redefine type. Okay, so I need to comment this out. Types any number and this are not compatible. Because I put an assignment on it. So if I say this is like, what I was trying to get at is I could do this, create a pointer, and then if I try to say blah equals, so if it's a pointer to exactly the same type, it should say, yeah, cannot assign. So I should not be allowed to do that. Basically because we just haven't written the code yet that supports it. Eventually you should be able to do that. But right now, no. Well, no, you shouldn't be able to do that, actually, because you want this to hold the pointer that is the result of this allocation. You don't want to assign something else over top of it. That doesn't make sense. Okay, so now we have incompatible types. This is at line 130. Yeah, because now this is an array of a specific size, not a slice. So we just need to convert it to a slice. Wrong number of parameters passed to procedure, and we don't have any file information. That's probably because we created these nodes and we didn't give any file information. So I guess we should. I guess the source position is node.sourcePosition. That's probably the best we can do. Maybe we can just give that to all of them. And then hopefully we get the right place. Yeah, so wrong number of parameters, expected 1, found 0. So we will have to add a parameter node here. I guess it's a child of the call. So the first child of the call is this, which is what procedure it is. Then the second child is the parameter. So that'll be a number node. I'm not going to give it a value yet. Because at this point, because the value should be the size of the thing we're allocating. But to know the byte size of something, that's like a generation thing. And we can't rely on generation because we'll end up with a cyclic thing. So I think that's what I want to do here. It's a little bit hacky, but we'll just create the number node with no value. And then here, because we know the structure, we can say this is the right-hand side. Yeah, that's the right-hand side. So this is the right-hand side. So we want the second child, I think. Right-hand side, maybe to make this clear, I'm going to say RHS node. do we use the RH? We do it down here. But is it guaranteed that we're going to have an RHS node? No. Okay, but here we know we have one. And the second child of the, well, the second child of that node is the param node. So the param node value equals, I did change a few names of procedures. So a lot of these sizing ones, now they're like 2 byte size, 2 defined size, 2 operation size, 2 precision size. So I did change, yeah, in my refactor I did change a few things. Nothing too major though. Okay, so we need the type node, so it'll be the left-hand side type node. But this will return a number and we want a string for this. So we're gonna have to convert, which means we need some bytes to temporarily use. I to A. And then I think we say buff, and we need to convert it to a slice. Like so. So that should assign the correct size. So we've allocated on the stack, and then this here should ensure that when we come down here and we generate our expression for the right-hand side, it should call allocate heap or allocate VRAM with the correct size. Info to the allocator call. Okay. So what happens actually? Failed to generate. Okay, let's get some more specifics. So this should be allocator equals heap or VRAM. I'm guessing allocator is VRAM. Yes. Okay, let's try that again. Assertion failed. Looks like that was one that I intended to have fail. Yes, because we haven't implemented our allocator. We should probably test this heap allocator too. Maybe let's do that first. So foo is a pointer to an I64 allocated on the heap. Foo is 42, exit with foo. Well, standard lib exit with foo. We need to dereference foo. Okay. I think we need to do that like before we create the window. Otherwise we get multiple threads and it doesn't really actually exit. There we go. Let's have a look at the assembly just to be sure. Not test, example. So yeah, so here we're copying 8 into the parameter, the top of the stack, which is the parameters, calling allocate heap. And then this should be, this should be the return value, which we put here, and then we copy it. And everything works properly, so that I'm assuming it's all fine. So and allocate heap. These are our 2 variables here, these ones. And then it should call mmap. So yeah, I think it's all good. At some stage, I think I would maybe like to change our calling convention because this feels a bit long-winded. And also inline procedures would be nice. Okay, so I'm happy that our heap allocation works. Our VRAM does not, because it's not filled out yet. And to fill it out, if we're going to do this, it means we need to rely on OpenGL. So I'm going to gl.bang. I'm going to split this code out so that all of our definitions are in separate files, like library files. And then we'll do like import them. And something else that I'd like to do while we're at it is say link GL. So this should link to the OpenGL library. Because I don't know if you remember this, we did it a long time ago, but yeah, don't hard code this stuff, because we've just got it hard coded that whenever we do a compile, it will link to these libraries, which is not the greatest way to do it, I want to say. So let's add to our program some links, which would just be a dynamic list of strings. And when we compile, I think, oh, we have to prefix it like this. I think we will return program. So we have this program. I think that color means that it's like shadowing. I don't like that shadowing is loud. In my language, it is not. And then we need to take the, and then we need to make some links. So I think if I just declare an empty string and then say for link in the program.links, link equals strings.concatenate space -L, I think is the prefix that we'll need. No, actually it should be link space, no, links space, so the existing stuff, then a space -L link. Yeah, because we have spaces in front of all of them, and we have space -L in front of all of them. So this should just be links. And now we're not hard coding. I think that's about it. But now we need, I think it was an AST where I put it. I need to remember where I put everything now. There's all these procedures that are like, you know, is it an import? Is it a type alias? So now I want to say like, is it a link statement? Which should be, should be a call. Should be just a call. If it's a call, so maybe it's something like this, but the statement is a call. So if it's a call and the name of it is link, that'll do. I don't know how bulletproof that is, but it'll do. And then in type checking of a module, so this is where we do the imports. So I guess before the imports, we can have maybe another loop. And if it's a link statement, then we can handle those. So I guess with this one, it is, we just get child 0 is the name. So I guess child 1 is the parameter. So that's like the link. but we probably do want to check first. Is it underscore found link slice.linear search? So if our program links, I think I have to turn that into a slice, already contains, I was supposed to do this up here, already contains the link, then we do nothing. We don't need to import it twice, right? In case we get two libraries or two modules that rely on the same one. Well, I guess it's the value. Is that happy? I think it will be. Then we append the link, like so. Is that really unhappy? Pointer to string. Ah, because I've got this here. Okay, that's happy. So that should handle the links. And I think probably here when we're generating statements, just like we do with imports, we should skip links. Okay, let's see if that works. But the idea is that hopefully now, hopefully now this will link GL. And let's create some more. We need GLU. Should link, oops. Let's maybe copy this. Oh, didn't I just create a file called GLU? Where did it go? Huh. Okay, I'm a bit confused about that. I thought I just created a file. I don't know what I did. So this is GLU, and if we go back here, I think there's like, this is it. This is the only thing that there is to it. Okay. So we should be able to cut that out. And now GLFW. GLFW. And that's lowercase, that one. Like so. All right. So those are all of our, I think all those libraries that should be good. There is a couple more. I had to define them in here. They are like GL compile status. Put that there and make it static. And GL link status. Bring those in, and then we just need to prefix everything. GL dot. GL dot, GLU dot. Here's another LMN, GL no error. So that should be GL.GL no error. GL.link status, GL.compile status. Like a saw. GL.GL dot. GLFW dot. Maybe I'll just do the rest of the GLFWs. GL dot. What else we got here? GL. Okay, I think that covers everything. Let's see. So link is not defined. That's right. I do think in type checking we need to, kind of like we did with import, I think we need to link it. Link it. We need to like provide the type information for it. So it has one parameter, which is the name, which is a string, and no return type. How about that? GL float is not defined. Where do I use that? 66. GL.gl float. Window should not close. That one needs to be prefixed. Color buff a bit, and GL triangles also. Okay. Okay, so now it's saying that these symbols are not defined. That's interesting. Probably when I go to generation and I look at the generation of, I think I just left it in program. So this program file now, it has like, you know, the top level, all the sort of general top level stuff, the assembly, and then it also has these procedures like generate procedures, generate statements, and down the bottom here, generate static vars. And all three of those procedures are in the same file still. But this one takes a set of statements, which is the main procedure statements. So it's only in the main procedure it's just like in our case, it's this module. So it's not going to do it for any other modules, which is not right. So I think we should probably cut that out actually and do something similar to what we do for generate statements, which is to loop through the modules. Like so, but instead of, no, yeah, we want to get the main procedure statement still. So it's pretty much the same, but now we're specifically trying to do our static vars. So hopefully that will work. Oh, we need to take out the parameter here. We don't need it anymore. Okay, so we get our assertion again. So now that's because we want actually to have basically this code here. And now we can do GL equals import GL. And then we can do a GL dot. Like so, and return the result of that. We don't have this check procedure here, so I'm just going to cut them out and hope that nothing goes wrong. Buffer size just becomes size. That's our mystery variable that we don't actually see, but we can use. I guess we need this hints thing. And this buffer name. Okay, we do need buffer name, although we never return it or anything. But for now, that should be fine. We don't have any way of deallocating. Like once it's allocated, that's it. You can't deallocate. That's okay, I think. So now this should work, I guess. You know, we've cut it down to this one line, which I think looks quite nice. How's that going to work? Module GL has not been imported into standard lib. Huh. Well, that's interesting. Because it clearly has been. So when we go here, it's like, I don't know what GL is. Let's have a look at this error. Module GL has not been imported. By the way, that should be GL and GLU. But when I go to GL, yeah, the links are correct. Okay. So module GL has not been imported. And that's coming up here. So it's not finding the module. So module name. So it's not in the imports. So it's type checking the module, type checking the procedures in the module. So this is the module. It should have all the identifiers from running through here. So this is the same code that any module goes through. Okay. Okay, I think I know why. Because we cut out early. If it's already been imported, then we cut out early. But we still need to add it to the imports of this module. Okay, so now we get a black screen of death. The enemy of any graphics programmer is the black screen of death, because you don't know what's going on. And we crashed. And I noticed looking at, because I just checked that the video recorded properly. I know I'm overexposed, but what to do? You didn't come here to see my face. You came to see the code and see the code working. So we get a black screen and hopefully not a crash. So let's look at the assembly. This is where we allocate the VRAM. And the thing to notice here is this is the parameter going into the allocation, and it's copying, it's saying, so this is the size that it's passing into allocate VRAM, and it's passing in 8. And that size is not correct. We actually want like a ton of bytes. You know, we're allocating this many VEC3s. So it should be that times 12. It should be a big number. So if we go into generation and assignment, I want to say, this is where we added in. So this type is actually the type of a pointer. So we could even say to byte size of this, but now we want to byte size of children 0, which is to say the thing we are pointing to. There we go. Now we have triangles. Now we have triangles, because now we have a big number here. Jackpot. Oh. And I forgot to turn my timer back on. Cool, that was the main thing I wanted to get done in this session. We had like a little bit of the side questiness because we split out our library files. And yeah, we split out our library files, and we also got that link thing working. If I look at our to-dos, I wonder if there's anything that stands out as something we could kind of fix up. We've got quite a few to-dos. So this one stands out. Here I was saying maybe we should change it to this in some places, because this is saying, basically this is saying we need whatever this value is to be in a register. But sometimes what we really need is that we just don't want it to be in an immediate. So the 3 location types in assembly are register, memory, and immediate. So if we are in memory and we really need to be in register, then we do this. But if we are in memory and memory is okay, but we don't want to be in an immediate, then we should do this. So I just want to find everywhere that we do this and just make sure that it actually makes sense. So for negation, we want location to be in a register apparently. And I think that makes sense. If we're doing neg, I'm pretty sure, well, maybe it doesn't need to be in a register, but this one I think will need to be in a register. Negate, location, and that's an immediate. I think that's safe. I'm not going to be too strict, like just if anything stands out as something that we could change, then we'll change it. But so the sign mask we put in a register, is that really necessary? It's in memory, and we specifically changed it from memory to a register. I guess that is needed, otherwise we would have just left it in memory. Copy to register, dereference, and then we treat that register as memory location. Yeah, I'm pretty sure that's needed. I do remember working on this stuff. It's not that long ago, and I'm pretty sure copy to register was needed. This is all like slice, and this is all indexing stuff. Copy to register the result location. Whoops. Yeah, I'm pretty sure the thing on the left-hand side, it's best to keep this in a register, so then this could be anything. If this was memory, then this could not be memory. So by putting this in a register, it gives us the freedom that that could be anything. I think we probably have, well, that's obviously specifically we want it in a register, that's why we're calling it a register location. Same with those. This is a result location, so probably something similar. Yeah, it's going on the left-hand side. Register location, result location. Yeah, I think this is all pretty result. Yeah, I'm pretty happy. I think it's fine just to have it like that. So that gets rid of one of those. This platform defendant, I realized that we can actually do, we can just use the size of in Odin, and it has a CInt type, like our CInt type. But in Odin, you have to actually import core C, and it's a member of that, which is not a bad idea. Makes it a bit more explicit, you know, that you really want to do some sort of C interoperability. So that takes care of that. Trailing commas, let's not worry about that stuff. I don't think I want to touch any of those. This test stuff. Move out of here. Yeah, that we'll do later. Okay, I think that's all of the to-dos that we'll take care of for now. Just run to make sure it's all good. We do have a few minutes left still, so let's have a look at our list. Split standard lib into multiple files. So yeah, actually that's a point. We split these into multiple files, but this one here itself, I would like to split up. So actually I think I'm going to make like a, this is also a Python Odin sort of organization thing, but we'll put these in vendor and put that in core. And we'll go core OS, Linux. So this is just going to be the syscalls basically. The wrappers for syscalls. We don't want our allocators here, exit, few ticks. These are extra things. Start thread. It does, yeah, I want to say that's not supposed to be in here. This is all threading stuff. Yeah, so these are all the syscalls actually. There's not many syscalls we've implemented yet. That'll do for that one. I think we have like a strings, core strings, so that'd be our prints. And we'll leave I to A in there. So just print an I to A, that'll do. What else? Threading, I guess. We'll have quite a lot. So syscall, right, print line, mmap. Threading, so that will have like our mutex, semaphore, start thread. Unfortunately, this will need to be here because it's like in our thread pool stuff. Thread pool boomstick. And then I think we can just rename this to like debug or something, because that's just going to have our assert. Oh, we also need, I guess, memory, which will have our allocators. Yeah, memory, threading, and debug. Is just assert. Cool. So now there's going to be a whole bunch of stuff that it's like, I don't know what this is. Yeah, it's trying to open a module that it can't find, which makes sense. So in our main program, we have to say, now we have to say vendor slash, and I guess like core slash whatever it is, we're using. We use a bunch of stuff, so definitely threading. We're going to have to import memory. Even though we don't actually use this, that's a bit hacky. That was already the case that it was hacky like that. It's just a little more obvious now. So that's a Linux syscall. What else do we have here? That's threading. That's threading. That's strangely threading. So this one is Linux. Oh no, actually we want to find standard lib. That's strings. Strings. Okay, and that is debug. So we need debug element OS Linux and strings. Maybe that's enough for that file. Failed to read module file. It would be nice if it referenced like which file is trying to read it. Entry module file. I guess I'll call it that, whatever. Name. And then here, it's like module file that imported by. Context.module name. So now if I run that, imported by example. Okay. So why can't it find vendor glfw? And why does it call it standard lib glfw? Oh, I think actually my import code is like wrong. See, this is like the left-hand side. So it's actually looking at this, not this. Yeah. That might expose more bugs. Let's see. So the right-hand side node is number 2. So that's like the reference, and that's the name, and that's more like the path. So the right-hand side node is a call node. So the first child of that would be the first parameter, which would be a string. So that should work. Yeah, and I think this kind of stuff we don't really need apart from for the path. So we use the path there. Let's see. I think that kind of makes sense and hopefully works. And then in, is it in main that we do the other import? I think it's like right at the top of main here. So maybe like that's the name and the path is strings.concatenate just with .bang. And the path goes there. Don't know. Does that work? Failed to read module file. Well, it's got double quotes around it. I think that's why. But this is already a nicer error message, isn't it? So this value, I guess we can say like name equals a slice of name which cuts off the front and back, so it should cut off the quotes. Print is not defined. Okay, yeah, that's kind of expected. So if we go to debug, yeah, it wants to do these prints, but they're not defined in this file, so we need to import strings, which is core strings. Okay, now in strings we find that write is not imported, so we need OS Linux, because write is a syscall. And here, I don't think this would use any syscalls, this one. No, it's more of a high level procedure. Cool, exit is not defined in debug. Oh, I missed that one. So that'd be core OS Linux, because that's a system call. Failed to read module file GL imported by memory, because that's vendor GL. mmap is not defined, so we need core. Yeah, actually, this does make me feel like that should be like that somehow. I don't know, core feels like it should go first when you're importing. So what do we want? Core OS Linux, I believe. We want Linux mmap. I think that should take care of that one. Futex is not defined. Futex, so in threading, and Futex is a syscall. So linux.futex, futex, lots of futexes, mmap, linux.syscall I guess we need to do. Anything else? Probably not down here. Oh, we do have a futex. How's that? Exit is not defined in threading 53. Linux.exit. Futex is not defined 109, so I guess I missed that one. Standard lib is not defined. Example 0131. So if we've got here, I guess all of the imported files have gone well. Standard lib is not defined. line 31 of example. Where did I use standard lib? Oh, well, all the tests use it, so they're all going to fail. And I used it here. So what does that need to be? I guess that needs to be core/memory. Does that work? Core/memory is not defined. So it should be in the identifiers. Oh, so in the identifiers, it's memory. So this is quite hacky. Since we have so many files now, I really have to just find out where the hell this is. Oh no, it's not that. It's where I did that here. So I guess that should just be memory, but that's relying on the fact that you have an import of core memory with an alias of memory. Yeah, now it works. So that's pretty hacky. Need to do something about that. But it's kind of cool that we have I don't know, a more proper standard library, I guess. With everything kind of split out nicely. Yeah, that should not need to have anything changed. That's fine. Cool. Okay. We're at now 10. So I think that's all good. I think that's quite successful. This was the main achievement here. We'll have to come back sometime and allow us to put vertex count in here. But that's a big improvement over this. So next we want to be able to do boomstick. Next thing is we want to be able to do boomstick at GPU. That's going to be interesting to implement. Okay. Okay. Should I tempt fate? Let's tempt fate. And actually, I realize we will need to fix some stuff here. Yeah, standard lib. So, and it should be pretty easy to do. It's just all of these tests have this, which we want to replace with core debug, and debug equals like that, and then that should be debug, like so. Then all the tests should hopefully work. Fingers crossed. Dangerous to do this right at the end of the video. Okay, cool. All the tests worked. Great. Okay, enough for today. Thanks for stopping by. Have a good one. Ciao for now.